Assalamualaikum and hi everyone. In this video, we're going to see the example of load line analysis for emitter bias configurations. But before we proceed, I hope you watch my presentation on emitter bias configuration and also on design operations. Okay, this are the questions which is required to DC load line on the characteristic curve, and then the second question required to calculate the value of RB to establish the operating point at IBQ equal to 30 microampere. To solve this question, you need the knowledge from the design operation. For the third one, by using all the result obtained from 1 and 2, find the value of ICQ and VCQ. Okay, for the first question, this the load line analysis. So what you need to do is, first one, you have to get the value of IC saturation, and then you have to find the value of VCE during the cutoff. First of all, you need to use the KVL. The KVL is plus VCC plus ICRC plus VCE, and then plus IE RE. The first point to find the value of IC saturation. During IC saturation, the information we have is VCE is equal to 0 volt, and also the another information is IC is equal to IE. So just substitute this information into this VL. So VCC just now we have the value of 20, so plus 20. IC the value that we need to find, so this one going to be IC saturation, and then for the value of our IC is 2 kilo ohm, so times 2 kilo ohm, and then we have the value of VCE. Okay, VCE is 0, and then for the IE is will equal to IC saturation, and then for the RE is equal to 500 ohm or 0.5 kilo equal to 0. And then by solving these equations, you find that IC saturation is equal to 8 milliampere. And then the second point, you need to find the VCE at the cut-off region. So the information we have is IC is equal to 0 milliampere. So just substitute this value into the KVL. VCE is equal to 20, and then IC is 0, so ICRC is 0. VCE, the value that we need to find. Okay, and then IE is also equal to 0 because of the IC, and then this is the 0 equal to 0, so you find that the VCE is equal to 20 volt. So you have these two informations. So what next is you have to plot. Okay, I just clear all the ink. So if you remember that we already find that the value of IC saturation is equal to 8 milliampere, and also the VCE is equal to 20 volt. So just plot here, and also we have to plot here, and then draw a line. So this is your load line. Okay, for the second question, calculate the value of RB to establish the operating point at IB equal to 30 microampere. First, what we need to do is we have to plot the intersection line is here. This is the IB equal to 30. Okay, from this point, we have to find out the value of VCE Q. Okay, and then and also the value of ICQ. So the value of ICQ I can say here is 4.1 milliampere, and also the value of VCEQ here is around is 9.5 volt. Okay, to find the value of RB, we cannot use the CE loop anymore. So what we need to do is we have to use the BE loop. The BE loop, we have to start with the KVL. So the KVL is you can start from the VCC, and then plus IBRB, and then we have the voltage drop at the VBE, and then we have the voltage drop at the RE. Okay, this one should be equal to 0, and then substitute all the value to find the value of RB. BCC is equal to 20, so it's minus 20 here, and then IB is here, the operating point, or I can say this is a IBQ. Okay, this is a 30 micro ampere, and then we have to find the value of RB, and then the value of VBE is 0.7 volt, and then IE is equal to beta plus 1 times with IB, which is 30 microampere. So we find the value of IE is equal to 4.03 milliampere. So IE here is 4.03 milliampere. The value of RE just now is 0.5 kilo, equal to 0. So by solving this equation, we will find the value of RB is equal to 576.17 kilo ohms. So for the third questions, by using all the result obtained from 1 and 2, find the value of ICQ and also VCEQ. Okay, actually from this question, we already did the value is we can get from the load line analysis. Okay, this is the value for ICQ and also this is the value of VCEQ. But for this question, you probably ask me to verify the value of ICQ and also the VCQ. So how to verify? We have to use the calculation method. Okay, for the ICQ, we can use this equation, which is ICQ is equal to beta IBQ. Okay, the value of beta right now is 133.33 time with IBQ. Just now we used 30 microampere. From the calculations, the ICQ is equal to 4 milliampere. So for the VCE, we can use the KVL. So please refer the previous KVL. So just rearrange. So we'll find the equation BCE minus ICRC minus IE RE. So the value of VCC is equal to 20, and then the IC is 4 milliampere, RC is 2 kilo, and then we have the IE equal to 4.03. Okay, we already calculate the IE just now, which is IE equal to beta plus 1 IB, and then the value of RE is 0.5 kilo ohm. Just calculate this value, so the value is 9.985 volt. So just now the graph we get the 9.5, but actually when we calculate, the value is 9.985. So it's just a small error between the calculate and also from the graph. Okay, that's all. Thank you for listening.